We are going to use the notes from Module 14, Part 1, where we were trying to find the z-interval for the population mean as the example that we are going to learn the calculator steps for. So in the notes that just were the video notes, lecture notes explaining what the interval for the population mean is, we did it by hand. So if you would like to go back and look at that, that is a separate video, but this video is all about doing it using your calculator. This is only for finding the z-interval for the population mean, okay? So not the actual population proportion, all right? So this question gives us, the Washington State Department of Ecology reported that the mean lead contamination in trout and Spokane River is 1 part per million with a standard deviation of 0.5 parts per million. Suppose we sample n is equal to 100 trout. So let's see if I can highlight. Let's see if I can highlight all of these things that I'm going to need. We need the mean, the standard deviation, the sample size, and we also need our confidence level, okay? Then once you have those 4 numbers, you're going to go to your calculator. You're going to hit the stat button, right arrow over to tests. We want the z-interval, so we're going to arrow down to number 7. Okay. If you had entered data in the calculator, you could do it that way, but in this case, the problem literally gave us all the numbers we need, so we're going to make sure it's blinking or highlighted on the stats part and not the data part at the top of the calculator. And I think I already entered these numbers in. Our standard deviation was 0.5 parts per million. Our mean, population mean, was 1 part per million. The sample size we chose was 100 trout. The confidence level we're looking at is 95%, so we put 0.95. Then we're going to calculate. And this gives us our interval. So we are 95% confident that the mean lead contamination level for trout will fall in between 0.902 and 1.098 parts per million. Okay, so like I said, please go back. We did this by hand. If we want to go ahead and do the second part, it's a little bit different, but construct an alpha equals 0.10 confidence interval. So what that means is if alpha is 10%, our confidence level is going to be 90%. So all we have to do, and we already have most of it typed in, all we have to do is go back to stat, whoops, I'm going the wrong way, stat tests 7, and you could just press the number 7 if you wanted to. And everything's the same, but we're going to change our confidence level to 0.90, 90%, which should make our interval longer because we're more confident that we're going to get more of the numbers. So that means kind of our range is larger. Our net, in order to catch all of those numbers, needs to be larger to have a higher confidence. Oh, I'm sorry, it's a lower confidence. So I said that backwards. I don't really want to do this video, so I'll say it again. It's a lower confidence level, so our range should be shorter. So, and yes, it is. So we are 90% confident that the mean lead contamination for trout in that river or lake is going to be 0.91 parts per million to 1.08 parts per million. All right. Oops. I meant to end the call, but I'm just pressing buttons. Please let me know if you have any questions.